We're talking about a potential breakthrough that could completely change how we think about computing. Imagine taking the incredible power of a quantum computer and shrinking it from a massive, super cool laboratory down onto a single tiny chip.
How in the world do you get the phenomenal problem-solving power of a quantum computer without the giant, incredibly fragile, and absurdly cold freezers they need to operate? When it comes to humanity's hardest problems, we've been stuck between a rock and a hard place. On one hand, you've got these cryogenic quantum systems. They can do amazing things, but you have to cool them to temperatures colder than deep space. On the other hand, you've got our trusty classical supercomputers. They work just fine at room temperature, but they often get completely bogged down on these complex problems, and they use an absolutely enormous amount of energy. This connection suggests that you don't actually need a true quantum system to get quantum-like behavior. You just need a classical system that's cleverly designed to act like a quantum one. They created a brand new type of processor based entirely on this principle. They call it Apollo. It's a neuromorphic processor with 10,000 nodes, designed from the ground up to solve these huge problems, all on a chip that works at room temperature. And at its very core, it's not using a classical bit or a quantum bit. It's using something new, something in between. This is the p-qubit, or probabilistic qubit. It rapidly jumps between 0 and 1, harnessing real quantum randomness to explore possibilities, but without needing that delicate quantum coherence. We're looking at a chip that delivers quantum-like performance. It runs at room temperature, and it uses less power than the little charger you plug your smartphone into. I mean, the leap in efficiency is almost hard to wrap your head around. A research paper states that Apollo's performance showed scaling trajectories that were, and I am quoting directly here, indistinguishable from the cryogenic quantum hardware. In other words, the little room temperature chip performed right on par with the giant, freezer-sized quantum computer. This isn't just about a faster, more efficient chip. This really feels like a paradigm shift in what's possible. And who gets access to this kind of computational power? You're talking about accelerating drug discovery, designing revolutionary new materials, creating smarter financial models, and maybe even training the next generations of AI. All of these huge fields are bottlenecked by exactly these types of massive optimization problems. This technology points toward a future where that same power could be accessible, efficient, and scalable. So you have to wonder, what new frontiers will we cross when the power to solve the unsolvable fits on a single chip?